had a 4 to the x. So I got a whole number to an x. What did it look like?
Like a 4.5.
What did the graph look like?
It rolled the thing and then I go wild.
It went, yep, it started low. Where did it start at? What number was it close to?
0.
0, and then it went
Through 1.
high. Why is it not right? Okay, what did the fraction do?
It rolled the thing, but it went up sooner.
What did, nope, nope,
Slower.
nope. Fraction, what did that do?
Slower.
Went faster.
Up and over.
Slower.
We are not working on worksheets right now. That was homework. You are doing notes at this time. Now, put them away. Okay, what's the fraction do?
Wait, didn't it go down?
No, let's not go down it.
Straight.
This one started low and went high. What did your fraction do?
Straight.
Look at your things that you did. What did the
Diagonal.
fraction do? It started high and went low. So this guy flipped.
What?
All right. Now, what did the number in front of it do to it? So
Go
How's it go
faster.
down?
it made it go up at a faster. It has the same rate, right?
It
But
didn't.
where it crossed
Once
was
they reach
different.
that point, it
So
goes
it's like the bigger the number, the faster it is.
Yeah, because like all of them crossed at 1, right? But if I multiplied it by 2, where did it cross?
2.
At 2. So it started to go up sooner, right? Okay, so the number in front is how fast it went up. If it was a whole number, not a fraction or a proper fraction, it was a, do you remember what that's called? Growth or decay function?
Nope.
What's this one called? Growth or
Growth.
decay?
Growth.
This is a growth.
Okay. Next.
On
And
the
this one here
negative.
was a decay. All right, that's what we did when we did our
So is that just
calculator
a
lab.
positive, negative?
Decoy.
Oh, what was the negative? Do you remember? Like say if I gave you a negative 3 to the x,
It went. It
It
started
went-
out low, but then it went
it went down.
down.
So it went like this, it flipped it over. Good job.
Yeah.
All right. Getting it.
Are we gonna have to label it as like growth?
Growth and decay, yes, we will, but not until 9%.
So is it a negative 3x decay?
Say it one more time.
Is the negative 3x decay?
Yes.
So pretty much
It's a weird one, but it wasn't classified as decay.
Wait,
growth is going up positive.
wait,
and decay.
wouldn't, but what if it's,
Go ahead.
okay, so, but wouldn't growth always be up and then decay is,
Starts high and goes low.
Decay, you start as an animal and you decay into nothing.
All right, now we're going to do these by hand. And we're going to graph -2 to 2 always. So the very 5 easiest exponents we can get. Now you have to remember what this means. So we're graphing 3 to the x. That's my parent graph. Everybody good? So this first one is 3 to the -2nd power. Okay, this is all done in your head. What's the first thing you do with the -2? You square it. So 3 squared is 9, but what does the negative make you do to it? Makes it, not negative,
Go down.
decay?
What's that answer? What's
Goes
3 to the
down.
-2?
It's positive
It's
9.
not 9.
Negative 9.
It's not, it's 1 9. Remember, a negative exponent is in the wrong place. So 3 squared is 9, but it can't be in the numerator because negative means it should be in the denominator. So my first one is -2 1/9. Remember, as close to 0 as we can get, but not actually being on it. Okay, let's try the -1. So what's 3 to the -1?
3 1/3.
1/3, because 3 to the first is 3, but then it has to go to the denominator.
Negative because the 3 times the -1 is the -3.
You're not taking 3 times the -1. It's 3 to the -1 power. That just means, remember, negative exponents are in the wrong place. Okay, you also have to remember definition of 0. What's 3 to the 0? Oh, I forgot to correct that. Why did-
0.
No. Any e to the 0 power is 0. 1.
1.
Definition. Anything to the 0 power is
1.
You should have known that. Where did all your graphs cross?
1.
At
The
0,
cross.
0.
1. Okay, what's 3 to the first power? 3. 3 squared? Okay, what would 3 to the third be?
27.
27. It gets really high really quick. Exponential growth or decay?
Growth.
Growth. Okay, so we know it's a growth function. Now we have to remember domain and range.
When will we use this?
Ooh,
That one-
smartest kid in the class asked the question.
All right, here we go. You guys, when you're doing this, what's your domain? X's or Y?
Y.
X's.
X's.
What can X be?
Any number.
Any number, so that's all
Real.
reals. Remember the weird R?
Do we have to do that?
All reals. You can write all reals. Okay, range is what? X or Y?
Y.
Y. Now look where Y has a value. Does it have a value at -3?
No.
-2?
No.
0?
No.
No, but the
No.
minute I pass 0, yes. So Y has to be greater than
0.
0.
Will it ever touch 0?
Do we have to write that in there?
I bet
So will it just flatline?
Do we have to
Will you be able to see it?
This is not okay. Do we have to write the domain and range?
Yes.
So, like, I tried showing this stuff to my dad, and he didn't know what you were talking about.
Well, my dad didn't do
He
that.
was like, I've never used
Either.
this.
So every time like you the Y has to be greater than 0.
He has, he just doesn't know how many grows in the base. So tell him he has used it, and if he didn't have it, he'd be broke.
He uses simple interest.
Oh, this is correct.
He doesn't make
Told me
it
that
seriously.
he didn't do 9 point, like the stuff we have in the 9s, so he uses advanced math.
All right. So do any of you have anything logical to say that's not wasting my time? No. Okay, let's go. Exponential growth function. How did I know this was a growth function before I
It started
graphed it?
low and went up high. And
Before you
started
graphed
negative.
it.
Started negative
Before
with
you
plastic.
graphed it.
Started negative with plastic.
How do you know by looking at the equation?
I don't know.
Why
The
is it?
equation.
Looking at the equation, you should know how to graph it.
Because it's
Yeah.
positive.
Why?
It's positive.
No.
The 3 was
The
positive.
number outside in the same fashion.
There you go. The number inside, the 3, right here, is bigger than 1. So if the 3 is bigger than 1, it's going to be gross. If it's less than 1, it's going to be decay.
Okay.
All right, so you have one to do. What's yours going to be?
Negative.
Okay.
Egg.
12 or 1.
You square it. What's 1/2 squared?
1.
2 4.
What's 1 squared?
1.
1. And what's 2 squared?
4.
4. Now, that's if you squared it. Now you have to deal with the negative. What's a negative exponent do?
Makes it turn.
Yep, it flips it, right? It's in the wrong place.
So it's 4 over 1.
So it's 4 over 1, which is what?
4.
4. So -2 is 4.
Okay.
So what is 1/2 to the -1 power? 2. Perfect.
So is it going up by 2?
No, it's exponential. It will never go up to the same amount.
So it only goes to the negative.
Yep. Okay, 1/2 to the 0 power. 1/2 to the first, oh, I better graph that.
Easy.
1/2 to the first power. 1/2. 1/2 squared. Good. You can borrow my graph paper, Keaton.
This is correct.
Okay, what's it approaching?
0.
0. So do not draw underneath the 0 because that's wrong.
Is that right?
Oh, yeah, that's correct.
Draw it up farther than the straight line. You gotta go farther than the first.
But that's where the dot goes.
Well, yeah, you have to go farther than the dot. There's more than one dot. That's just where we put graphing.
Yeah.
You can't go from dot to dot. You have to go farther than the dot. The graph continues forever. What, Christian? I thought you had your hand up. Any other questions? Are we good? All
Do
right.
you have to do the domain range? Or
Yeah, we do. What's the domain?
All real.
All reals. What's the range?
0.
Y greater than 0. Growth or decay? Decay. Why?
Wait, will it always be greater than 0?
Unless the top number is
Because
negative.
it's a fraction.
Because it's a fraction. So it's decay. And it's because we had a fraction. A proper fraction, I should say.
Written, Mrs.
Okay, next one. Oh, it was. All right, now we're going to go from, instead of giving you the equation and you give me the graph, I'm going to give you the table and you have to give me the equation. Now, it's going to be easy. Look at these. Let's go back to this one. All right, I have 1/9, 1/3, 1 3/9. What's happening every time? How am I getting from 1/9 to 1/3? What am I multiplying by? 3. How do I get from 1/3 to 1?
Multiply by 3.
How do I get from 1 to 3? And from 3 to 9. So if you multiply by the same number, Nicholas?
Are there any exceptions to that?
But I thought you said that they couldn't go up at the same rate.
They're not. They're multiplying by the same number, but that increases the rate.
But isn't it?
No, it
No,
doesn't.
it does
Like
not.
3 times 3 is 9. So it goes from 3 to 9.
Look, your distance is not the same. This is a distance of 2, this is a distance of 6. So you're not going at a flat. This, you are increasing. Yep.
So, will it always be times by 3, or will
No,
it be...
no, no.
Okay.
They're going to be different numbers. So
Okay.
this one here was 3 because it was 3 to the x. So it could be 2, it could be 4, it could be 10, it won't be ridiculous. Like it won't be like 17 or 28 or something weird that you don't know. It will be something that you should be able to see. All right, so if it multiplies by the same number, we get an exponential function. Fair enough? What if it adds?
I don't know.
Then it could just.
And those little shape, do you get
Oh, square.
a line? So if it's adding by the same, we've done that a lot. It goes up, it's a line. So the first thing we look for patterns in the dash. So the pattern is multiplied by the same number, I'm going to have a curve, some kind of exponential, growth or decay. If I add the same number, I'm going to have a
Straight.
line, right? Okay, if it's neither one, you don't know how to do it. And we're not going to learn how to do those in here. We gotta wait.
Yes. Yes.
I knew you'd be sad. Okay, here we go. First thing you want is all the x's have to go by 1. Otherwise, life gets really difficult. So we want them to go by 1. Yep.
But don't we have to learn that to know how to do the whole Shazam thing?
What if they didn't go by 1?
You are not, you don't know enough. So you will learn it, but not
Well,
yet.
why don't, but
You're wasting my time again.
Will we learn that in high school?
We are in high school.
What?
What if they didn't go by 1?
No, he's asking if we're gonna learn it like in.
Then you gotta figure out what the numbers in between are,
Yay.
which we don't want.
let's
Hopefully that's not
do
gonna happen.
that.
All right, here we go. Now we need to look. How do we get from 1 to 2?
Add 1.
I could add 1 or multiply by 2. Do I know which one it is yet?
No.
No. So then we go to the next one.
Multiple.
Am I adding 1 or multiplying by 2?
Multiplying by 2.
So this is times 2, this is times 2. You have to make sure they all work. Is this times 2? Yes? Is this times 2? Yes. All right. So that means it's 2 to the
Second.
x power. All right, because you don't know how many times it is. Making sense? Okay, your turn.
Oh, this is cheesy.
I'm done.
Sure is
3.
3 to the x. Did you check them all?
Yeah.
This was times 3, times 3, times 3. So, is it a growth or decay?
Growth.
Growth, because it's going up. All right, now. Okay, so you're graphing on the bottom.
Is that on the quiz?
Now we have to figure out what everything does. You should already know.
It goes up by 2x.
Okay, so, no. What is 2 to the x? 2! It's my what?
Dear, whatever we just
What's
did.
it called? It's got a very special name. Who is he?
Exponential.
He is my parent graph. Parent graph, it even has it in there for you. All right, so we do 2, I'm going to put it over here, to the negative 2. What is 2 to the negative second power?
1/4.
1/4.
1/4.
So go down and graph that.
We gotta do all those.
Negative 2 to the 1/4.
That's great. Go back up so I can see it.
Yeah, we are.
And Mrs. Carter, I think you're 1/4 though.
She's corny, we are.
No.
What do you do with negative 2?
Oh.
You multiply it by a negative.
No, they are exponents. They are not numbers to multiply.
Yeah.
So it's 2 to the negative 2 power.
Yeah.
What's a negative mean? No. What's a negative exponent mean? Yeah, it's in the wrong place. So instead of 2 to the negative 2, that means it's 1/2 squared. What's 2 squared?
So you just square it and then put
You
it
just squared.
Oh, that you just mind putting.
or put it under 1.
I shouldn't, because that's last semester. You've already taken a test over it.
Yeah,
one
but you
over.
see my name on the board? Explains.
Semester.
Yeah.
Pay attention. Okay, so 1/4. So now this is 2 to the negative 1. What do we get?
1/2.
1/2. So go to negative 1 and graph 1/2.
It's a grow.
Okay? 2 to the 0.
1.
1. So 2 to the 0 is 1. 2 to the first? Yep.
Can we just times the y column to
Then.
Yeah.
Up to
2. And then 2 squared is 4. Okay. Remember, it doesn't touch the 0, but gets very close. And
Boom.
goes up. So there is my
Easy.
parent graph. All right, now
Right over
you
here.
have to remember what we did with our calculators. So what happened when we multiplied it by 3 or by a number? What did it do to the graph?
Once it reached.
It made it go up faster.
Except it went up faster.
So I'm going to take every one of these numbers and multiply it by
3.
3. So we take this column
3/4.
and we multiply it by
3.
3.
3/4.
So that's 3/4.
1 and 1/2.
All right, 3 halves are 1.5.
3. 6. 12.
12. So it's how fast it went up, right?
Yeah.
So it goes up faster. 3. Okay, let's graph them. So you're going to take every point here and multiply it by 3.
Tree.
So this became 3/4.
3.
This became 1.5. 1 times 3 was 3.
Oh,
2 times 3 was 6. 4 times 3 was, I'm too short, 12.
That was
Okay, what's it going to approach?
Your line's a little bit off.
I know, I can't reach that high. So it's going to approach 0 like before,
Oh, let's see, you're trying
but
to reach.
now,
Oh.
I need to grow.
So curved.
Okay, so now it goes up. It's still going up at the same rate, but it started quicker, right?
It doesn't look like it.
Mrs. Carter,
Well, okay, fine.
you need to talk to the tech guys about getting you like maybe a step stool.
I am fine.
She's got
All
a
right.
right.
It's going
Now,
faster. No, she gets like a ledge on the bottom so she can step on it.
you need to like have like a
here we go. Let's
Purple.
do purple it is. Okay, what's the negative 3 going to
8
do?
times 3 grow
It's
by
gonna go down.
It's going to make it go down. So now, what am I going to multiply this row by right here?
-3.
I already multiplied it by 3.
No, let's just go back to the first row.
Oh, I can go by the first row and multiply by -3. Absolutely.
You multiply.
Or I can multiply the second row by -1.
Oh, that's easier.
So, -3/4, -3 halves, -3, -6, -12. What did it do? What did it do to my graph?
Go down.
So it flipped it, right? Okay, so now you're graphing that one, and I know I didn't give you enough room. So we're taking the red one and we're flipping it. So -1.5 here, Positive 3 is now a negative 3. The other one should be way down here at 6. And I don't have a 12. And so this one took my graph and
You didn't
What?
even line.
that's pretty good for me.
Well, you didn't
Gotta
even
give me
use
credit
the
for
point.
It is lower than
Oh, well. All right. So now we know that a positive 3 makes it go up sooner. A negative flips it. What's the 1/3 do to my graph?
Slower.
All right, so what's this like if we were doing a parabola? What would this 3 have done to my parabola?
Made it wider.
Would have stretched it. Am I still stretching?
Yeah.
Yeah. What did the negative do to my parabola? It flipped it. Did I still flip?
Yes.
Yeah. What did the 1/3 do to my parabola?
Made it fatter.
It compressed it. Is this still going to compress?
Yeah.
Yeah. Does this work identical? No, I'm showing you that what you know of parabolas is the same.
I don't know. Are we gonna do
Yeah.
the next two?
All right,
I
yeah.
talked to my dad.
So what's the 1/3 do?
Blue.
You want blue?
Orange. We're gonna use orange next.
Here we go.
No, I hate orange.
So I'm taking 1/3 times 2x. So which graph do I need to go back to?
The first.
I'm going to go back here and multiply by a third. So what's 1/4 times 1/3?
112.
112. Okay, what's 1/2 times 1/3?
1/6.
1/6. What's 1 times 1/3?
1/3.
2 times 1/3?
2/3.
And 4 times 1/3.
4/3. 4 and 1 and 1/3.
So this guy, he goes up slower. So this is truly a compression. And this one is truly a
Stretch.
stretch. Anything different than we've done in the past?
No.
Nothing. Except now it's just a funkier graph. So now we have to take all these points and multiply them by a third. So he's here, third here, a third here, 2/3 here, 4/3 here. So what happened to my growth graph?
Went up slower.
Yeah, it went up slower. He compressed him, pushed him down.
Hey, you got all the points this week.
I know. There are lucky days. All right. How are we doing? Can I go on to the next one? Are everybody keeping up all right?
Wait, what about the last one?
That's where I'm going. Can I move?
Orange.
Can you do like
Orange?
orange or maybe a puke brown?
No, use yellow.
I tried yellow. It's really hard to see.
Use yellow.
Orange, I'll go with orange. I that's orange. All right. Now, back to parabolas.
Are you sure?
What did Shaylin?
It's gonna be a
What did the +3 do to my parabola?
It just. Actually, there's.
What did it do to it? What did it do to the whole parabola? Yeah, it moved the whole parabola up three, right?
Yep.
So guess what this is going to do to my graph?
Move it up 3.
Move it up 3. No, because it's not that.
I'm thinking.
You're thinking a line.
Yeah.
Why is it like so?
All right, here we go. So, where am I adding the +3 to? Which graph?
The
First one. So I'm back to here, and I have to add 3. So what's 1/4 plus 3?
3/4.
3 and 1/4.
3 and 1/4. What is 1/2 plus 3?
3 halves.
3 and 1/2. What is 3 plus 1?
4. What?
Next one?
5.
Oh, so you're right. Sorry. 4 plus 3?
Stop on.
7.
That was on the next one. So it moved up 3. Now, is it going to approach 0?
No.
No, what's it going to approach?
2.
3.
No.
Because we're going to take your original green and we're going to go up 3. 1, 2, 3.
It's gonna be a line.
First one up 3. 1, 2, 3. 1 plus 3 is 4. 2 plus 3 is 5. And 4 plus 3 is 7. Now it's going to approach
3.
2.
3. So what changed? Oh, that's really bad.
Wow.
My domain or my range?
Domain.
No, domain is still all the,
Range.
Wait,
what's
wait,
the
wait,
range gonna
anything
start at now?
above 3.
Yes, it's gonna be anything above 3.
Wait,
Now, go ahead.
is this?
What, did you not look?
Well, I mean, yes, but.
Okay. All right, up here. Now,
See that? That was
voices off.
Yeah, well,
You know that this is your Y move, right?
Yeah,
3.
Okay, parabolas also had an X move, did they not?
no.
Yes.
Yeah. Where do you think an X move is going to show up on an exponential graph?
On the
No
X.
solutions.
Where?
0.
Where's it going to be in my problem?
Oh, the Y.
No, in your equation right here. If you're looking here, yes, your X move is going to be in your exponent. It's going to say like X plus 2 up there, or X minus 1. And it works the same way as a parabola. So if it's plus 2, it's going to move the whole thing
2.
which way?
That way.
Left 2. If it's minus 1, it's going to move the whole thing.
Oh, so it's like that
Right.
one chapter, like if it was plus 2 and that one. But I forgot what chapter that was when I do it, so that's why my name's up on the board.
All right, that's it. Now, questions over that? Are we
Wait,
okay?
we don't have to
Can we go back up to the
No,
graph?
you do have to graph
Could
that.
you make a parabola out of those?
Hey.
What's up? When this says not graph, this means the 34 through 40. All the rest of this is graph. When it says to
What was my
graph.
name?
Same here.
Yep.
What?
Oh, 64.